All right, good morning, everybody. I hope that you are getting along just fine with you and your family. We've had a couple of questions asked about 8.1. 8.1, the objective of this section is not only are we finding the average and standard deviation of a set of data, but we're taking this enormous set of data and we're breaking it down into several subgroups. We're finding the average and the standard deviation of each subgroup, getting all those answers. Then we're finding the average and the standard deviation of those subgroups, okay? So it's really two levels of statistics here that we're talking about. I strongly encourage you got to read sections 8.1, pages 1 through 6 before attempting some of these problems, and I think that it will make more sense. But here we go with some of these problems. It says the upper leg length of 20 to 29-year-old males is normally distributed with a mean length of this and a standard deviation of that. So this we actually covered in section 7.1 and 7.2, where we have a normally distributed curve. The average is smack dab in the middle. The z-score at that average is 0. And we're going to put the average in there at 43.7. The standard deviation, or sigma, is 4.2. We want to find out what's the probability that a randomly selected male from this group has an upper leg length that's less than 40 centimeters. So if the average is at 43, a picture of this is less than 40, somewhere down there. So we're looking for the probability that in this normally distributed curve, that person that I select lives in this small zone. Okay, most of you guys have the TI-36X Pro, and we can get that done. I hope you can see these computations. Yeah, we turn the calculator on. We go into the shift data and the distribution menu. We want the normal CDF. It's asking us for the average, check. It's asking us for the standard deviation or sigma, check. The next is the lower bound, and I know if you guys read the notes that are filled in, they use the TI-84 to do that, where it gives those 4 parameters. This is how we do it. It prompts us for those 4 parameters. And if you notice on our notes, it says that the lower bound is -100. Well, the normal bound that we use on our calculator is -infinity, or as close to -infinity as we can get. So this is negative with 1 with 99 zeros after it. So that is so close to -infinity. -100 works equally as well, okay? And the upper bound, in other words, -infinity on our picture is way down here. The upper bound is 40, okay? We want those femur lengths to be 40 centimeters, so we're going to put 40 for the upper bound. And then we calculate it, and there it is. Rounded to the nearest 4 decimal places, the probability of a femur length less than 40. If we change that to a percentage, it would be 18.92%. The next question actually talks about what we're dealing with here. A random sample of 9 men this time, not just one. What's the probability that the mean upper leg length is less than 40 centimeters? So again, the picture is just the same. We still have an average of 43.7. We still want all these 9 men to be in this zone, less than 40. But this time, the standard deviation is slightly different. We want the standard deviation of all the sample means, okay? the notation for that is this. Unlike the standard deviation for I'm just doing it for one person, this is the standard deviation for a group of people. And we often call this standard deviation of all the sample means the standard error. So given that we have 9 people, we have to calculate the standard deviation for this problem slightly different. So what is the formula for that? On the previous page, the formula is defined as the standard deviation for the entire population divided by the number of people that you have and the square root of that. So in this particular instance, the standard deviation and the number of people. So it's just 4.2 divided by the square root of 9. 4.2 divided by 3. The standard deviation now that I use for this problem using 9 men is 1.4. Again, that's the standard deviation of all of the sample means, and it's referred to as the standard error. So here we go. Let's plug into our calculator. Shift data. We want a distribution, a normal CDF, where the average is still the same, but the standard deviation has changed to 1.4. Stick 1.4 in there. Enter, or I just arrow down. That's negative infinity. That shows us that the lower bound is on the far left, and the upper bound, 40. Calculate that one. So this one is less likely. The more people that you have in the group, the less likely the event is to occur for all 9 men. Does that make sense? Rounded to the nearest 4 decimal places, and there we go. Let's do one last sample on this video. What's the probability of a random sample of 12 men? Again, same exact picture. That's not changed. That's not changed. That's not changed. The only thing that is changed is now we have to use the standard error. So it's the old standard deviation divided by the square root of 12. So the number of men is increased. So do you think it's going to be more likely or less likely that all 12 of these people sampled live in this zone? Well, it's going to be less likely, right? So let's find out what the probability is. 4.2 the standard deviation is that. We're going to our distribution. It's a normal CDF. That's the same. This is different. The sigma, or the new standard deviation for the sample means, or the standard error, is 1.21. I'm going to put it in there for 4 decimal places. That's the lower bound. The upper bound is still 40. Calculate that. Less and less likely every time you add an individual to this data. Which leads us to the next question. What effect does increasing the sample space have on the probability? Again, the more people that you're trying to shove into this small zone, the less likely it's going to happen. And that's it. I hope you understand that video a little bit better than just reading through the samples. And again, chapter 8, 8.1 and 8.2, the filled in notes are generated by using a TI-84 calculator. instead of our TI-36. So see if you can distinguish what they're talking about when they're talking about these types of values. That's the lower bound. That's the upper bound. That's the average. And this is our standard deviation or the standard error. All right, I hope that's helpful. Good luck. I will try to post some more videos here in the next couple of days. Your test is 1 week from tomorrow. So we have to have all this stuff in homework-wise by Monday, a week from tonight at midnight. Talk to you soon.